Hi, everybody. Good morning. It's great to be here. I'm Matt Digan. I'm from Brooklyn, New York, and currently head of data engineering at the New York Times. I oversee 4 teams there who work on data infrastructure and data pipelines and data APIs. We work with things like clickstream data, customer data, and advertising data, and we work with internal groups at the Times like marketing and advertising and finance, and data analysts and data scientists. Previously, I was director of engineering at Basho Technologies. Basho made a NoSQL database called React, and I managed a team that built a big data platform around React. We integrated it with Spark, Redis, Mesos, and some other systems. And I also managed the client libraries team and the team responsible for our build systems. Today, I want to talk about 3 things: our cloud migration, a big project that my group worked on over the past 18 months or so, the lessons that we learned, and then what happened next. This is a story of a group redefining itself, figuring out how to best serve their customers and collaborators, and falling in love with Airflow. But before I get into the story, I want to do some foreshadowing. So just like Chekhov's gun, a pistol placed on the wall in the first act must go off in the next act, I want to put this punch card here as a placeholder for something that happens later in the presentation. I should tell you a little bit about the company where I work. The New York Times, a small newspaper you might have heard of, a very mission-driven organization, the mission being to provide expert and independent journalism to all of its readers and customers. And we have 125 Pulitzer Prizes to date as evidence of that journalism. Now, the New York Times is a subscription-first business, and increasingly, a digital-first business. As of Q2 of this year, we had almost 4 million paid total subscribers, and almost 75% of those subscribers were digital only. There's still a solid base of print subscriptions, but you can see how the digital subscriptions are growing and growing over the past 7 years. And that growth is powered by the technology organization at the New York Times. There's about 500 people in that group, spread out across 75 teams. Of those 400 people, or of those 500 people, there's a mix of engineers and project managers, and the groups are roughly split into front-end and back-end teams. So examples of front-end would be the website, the homepage, the story page, mobile apps, cooking, and crosswords. And then the back end would be where data engineering lives, the content management system, the publishing pipeline, search, e-commerce, and marketing systems. Check out our open blog to see how we build our digital products and our engineering culture. So my team is data engineering. That's 4 sub-teams, approximately 25 people. We've got a team that builds data APIs and integrates with external systems and vendors, another team that handles our digital subscriber pipeline and builds tools and services that make up our data infrastructure, another that works on print subscribers and customer care data pipelines, and lastly, all of our DBAs in the enterprise are part of data engineering, and they're in the middle of a pivot from the traditional DBA role to that of a database reliability engineer, which is something you can think of as DBA plus DevOps plus automation. The mission of data engineering is to supply fresh, clean, trustworthy data to our entire organization and to allow other teams to do the same. And I think of that feeding directly into the mission of the data organization as a whole at the New York Times, which is to help the company understand its customers through its data. So I want to tell you about our cloud migration. We built a new home for all of our customer data on the Google Cloud Platform. We moved out of our 15-year-old data warehouse. We had a small set of goals that we wanted to accomplish with this cloud migration. We wanted to concentrate on data, not operations. We wanted to leverage innovation that was available in cloud services. We wanted to improve our delivery speed. But most of all, we had one goal driving us, and that was that we wanted to shut down all of our regular data centers. So as of 2 years ago, the New York Times ran 4 data centers, one in Boston, one on the 12th floor of our headquarters building in Midtown Manhattan, one in Newark, New Jersey, and another in Seattle. We wanted to shut them all down and move all of our applications and systems to cloud services. In this story, the customer data warehouse is the star of the show, or the target, I should say. And this data warehouse had hundreds of reports, public, private, hidden, used, unused, mission critical. We had to sort it all out. This data warehouse powered digital subscribers, home delivery, customer care, and was also used for forecasting subscriber growth. Our old stack here was Oracle, Informatica, Pentaho, and Business Objects. And there was even some Hadoop around there too. And there was even some Redshift. I count myself as lucky because we shut down our on-prem Hadoop cluster before I joined the Times in 2017. And work had already gotten underway to move to GCP. A large part of that was out of our data organization, my group, and their evaluation of BigQuery as a replacement for our analytical environment. As part of that evaluation, we spun up a small team that figured out how to port our clickstream data over to GCP using PubSub and Dataflow, and eventually landing all that data into BigQuery. It was a success, and we decided to go forward with this migration. But there was one hitch in our great plan, and that was our deadline. So when we started planning back in the end of 2016, March 2018 seemed very far away. But it got closer, and closer, and closer. So close, but we made it. We had the party, and we ate the pizza, and we popped the champagne corks. And then all of our data was in GCP. So, as I mentioned, it was all in BigQuery. That meant we had no more data silos. Everything was easily joinable to everything else. And we were able to create a single view of our customer by combining all the data that we had there. Daily processing time went from 10 hours of batch jobs down to 1 hour. Another team took over reporting, and engineers were able to focus on engineering of pipelines. This is the director of our data warehouse team up in our data center on the 12th floor, pushing the off button, or actually turning the key on this sunbox that hosted our data warehouse and turning it off for the last time. So this is right before we popped the champagne. We learned a lot of lessons along the way. I think we learned just about everything there was to learn about a large-scale project like this. We learned lessons about the team, the technology, the way we communicated, the way we planned, and our budget. When it comes to the team, we learned it's best to have two when you're moving to a new system, one for the old and one for the new. That way, the new team is always unblocked. They're not going to be called upon to fight a fire back in the old world and stop making forward motion on the project that's going against your deadline. We learned it's important to clearly identify all the roles of the project and to update everyone, whether it's people on the tech team or stakeholders, when those roles change so there's no confusion about who's the tech lead now, who should be making decisions. You want that to be very clear. We learned a lot on the tech side. One of the key takeaways for me was that you should implement your scheduler first. And by that I mean Airflow or Cloud Composer or Luigi, whatever's going to run your pipelines. And then develop all your pipelines using that. That way you avoid a second phase of your project where you've built all your pipelines or built all your jobs, and then you need to go retrofit them to whatever your ultimate scheduler is going to be. It's also important to have veterans of your new stack on your team. So it's good to have people that are learning and people that are ramping up the new technology, but it's good to also have people that have done it before. We learned a lot about communication. We learned it's important to frequently validate expectations with stakeholders, to describe to them how their business will change in the new world. If you're redoing all their reports that used to be in business objects and drove their daily operations, tell them what their new world will look like on your new reporting system. And then get the acceptance criteria from your stakeholders nailed down as soon as possible. So this is the gun going off. This is the mainframe that we worked with that was upstream from us providing data for our print subscription warehouse. This old guy has his own stuff going on. And the team that was responsible for moving the system that was hosted here into the cloud didn't have the time or the inclination to work with our change requests. And so we found it very tricky to coordinate the results when we wanted feeds to be changed or new attributes to be added to the data that this system supplied to us. So we learned a lot about dealing with dependencies. There's a couple ways you can tackle dependencies. You can do embedding, where you have members of your team join another team and actually write code to make the fixes or enhancements that you need. You could submit pull requests on these upstream systems and get them reviewed and accepted and merged by the teams that manage these systems. You could leverage project managers to go talk to other project managers and impart the criticality of the requests you're making. And then you can set expectations with your stakeholders that you're hitting delays and why the delays are happening. So when you hit those delays, like we did, it's important to stay closely engaged with your stakeholders. Don't go away and put your heads down in the corner and work on breaking through the problem. And break the work into separate streams so you can be able to route around those delays. So we were able to do this successfully with the mainframe that I mentioned, where we were able to go off and work on different data sources that didn't have those blocks. We learned an important lesson about our budget. It's important to create a budget. It's important to have a goal to know what you should optimize for. So you don't want to spin up giant clusters that are costing hundreds of dollars per day if that's not part of your budget. And lastly, have a solid plan B. So we didn't really have a plan B. We made a decision that we weren't going to do a lift and shift. We weren't going to take our old environment, the Oracle Data Warehouse, for example, powered by Informatica and business objects, and directly transfer that to our new environment. We decided we were going to rewrite our entire system. At some point in the project, we made a decision to move forward, and we knew that we didn't have any chance to go back if it didn't work out. I wouldn't recommend that. So where did we end up? On a new stack with Spark, Dataflow, BigQuery, and other GCP friends, and especially Airflow and Chartio. So interesting story about Airflow. We were part of an early evaluation of Cloud Composer, which is Google's managed service version of Airflow. We knew it was going to be great, but it wasn't ready to go for general availability. There were some glitches, so we went with team-specific Airflow instances. We set up one per team, and we delivered the project with that configuration. Now the Cloud Composer is GA, and it is available, and all of those glitches have been worked out. We're in the process of migrating from our individual Airflow instances to Cloud Composer. So we ended up with a structure like this. These are the teams that we have in our current configuration. All the teams that are in purple are powered by data engineering. And then the other teams that you see are part of our partner organization, which is where the analysts, data scientists, machine learning engineers, and report writers live. We think of this whole environment as a set of capabilities that we want to build out. So you can see data flowing into our analytical environment, orchestration, that's Airflow, and then the different capabilities that we enable with that data. This is the system that we delivered. We call it the home delivery system of record. This is sort of your standard diagram with data sources flowing through a data lake into a set of jobs that validate and transform the data, and then put it into BigQuery so it's available to be reported on with Chartio. That mainframe is the data source highlighted in red. So there's one more thing. It's everything else. We met the deadline. We shut down our data centers. We built a great new analytics environment on GCP, but we still had to deal with everything else. So Word, cloud. I got a lot of these dad jokes. I like to think of the way we did the project is we put everything in the back of a moving van. We drove to our new place, and then we threw everything into the new place. We still had to sort it out and unpack it. And what we learned is not only does the cloud change what technologies you can use, but it also changes your teams and your culture and the possibilities that you have there. We found that out, especially since we didn't do a lift and shift. We had a ton of questions. What kind of skills and roles did we need? How should we be organized? And what was our mission again? And these are the answers that we came up with. The guiding principle is that data engineering is just software engineering. So you can take best practices, and you can scale your team, and you can do more with less. We have a set of engineering values that we follow. Teams own systems. There's no throwing things over the wall. There's no data ops and other teams. We believe that we build it, we test it, and we run it. That gives us freedom to solve a problem as we see fit within the guidelines of certain languages and components that are supported company-wide. But that also connects us to a mission. And understanding how the work relates to the goals of the group and the company gives us that connection. So I think of it as assemble the teams and systems into capabilities and attach them to a mission. An example of a mission could be grow the number of digital subscribers, something that's important to our core business. So how do we deliver on that? One way is to think of our platforms and the tools that we build as products. And I think of that as a triangle of, that's something that can be managed by a triangle of product owners, engineering leads, and project managers. One of those sets per each team. So the product owner supplies the what and the why of what you're building. The engineering lead provides the how, along with the engineering team. And the project managers are responsible for communicating the when. And what does it mean to be a product owner? It's not a job title, but it's a role on the team, or it's a hat that you wear. Candidates for that could be an engineering lead that's taken on another role, a project or program manager that wants to move into a different position. But the role cannot be shared between multiple people. It's one person, it's one hat. And a product owner owns the roadmap. They talk to the customers and gather requirements. They're responsible for prioritizing the features and the work, and they communicate the impact of decisions and trade-offs to the stakeholders. We thought a lot about how we would collaborate with data scientists and data analysts and other people that were going to use our data. We thought we could best enable collaboration with Jupyter Notebooks. So we rolled our own version of something very similar to the Databricks service. We used Google Cloud Data Lab for Jupyter Notebooks. We used Dataproc to spin up Spark clusters. We thought that notebooks and Python could be our common language between us and analysts and data scientists especially. We even created a commit hook that would save the notebook in Python format so that we could do code reviews in GitHub and look at the diffs, because it's very difficult to diff the JSON format of a notebook compared to Python. We thought this would be a very popular way for us to enable collaboration, but it hasn't really taken off. The good thing about this approach is it's not very hard to roll back from this and just go to plain Python, although we haven't done that yet. So we wanted to figure out how else we could enable that collaboration, and we thought about our customers. There's essentially 3 types of customers that we have internally. Those that want to transform existing data that's already made its way into our analytics environment, data that's already in BQ. So we think, how can we give them tools to work with that data? There's other customers that want to load data that maybe they're responsible for, like an application team. Like I think of our crosswords team that's producing lots of data that's coming out of their application. So we can just give them rules and guidelines about how they should build pipelines and the features that those pipelines should have, like being able to recover easily from failure, being able to do backfills, things that analysts would expect that would be part of those pipelines. And then lastly, we have customers that aren't able to do the work and need us to do it for them. So in that case, we'll just do it. But it's important to unblock the people who can write their own code. So primarily, that's, for us, analysts and data scientists. And what we want to move towards is a way to bring those analysts and data scientists closer to the raw data. We want to let them create the intermediate transformations. We want to let them aggregate the data if they need to. And the data engineers become responsible for producing that clean, fresh, trustworthy data, that raw data. This is partially inspired by a blog post written by someone from Stitch Fix a couple years ago called "Engineers Don't Write ETL." So we're taking an approach to ETL that lets the data scientists and the analysts participate or collaborate along with us in the creation of pipelines. And we're thinking about things like the creator of Airflow has published a blog post that talks about functional ETL. And so, of course, this is supported in Airflow. And if we take this approach, we can use SQL or Python as a common language. Because it's based on the idea of pure tasks, and it maps one task to a table, it's very easy to reason about. And it gets us all using source control, which isn't a place where we were before. We're still working out how production support would work, because the idea is that the data infrastructure here would be the actual Airflow system, whether that's the individual nodes that I mentioned or Cloud Composer, Airflow operators that the data platforms team or the data infrastructure team would create as needed, and then the actual code for the tasks that anybody could create. So what we're trying to figure out is, how do we support that in production when it breaks? How do we know what the first line support is, second line support is, and so on? And how do we give people debugging tools to be able to figure that out quickly and pass it off to the right person? Also, internally, we're building community. So we've established an internal community of practice around ETL, and we've also started organizing the local New York City meetup for Airflow. And we're going to use that for a variety of things. One, to talk about what we do in data engineering at the New York Times, but also what it's like to work at the New York Times and why you might want to work there. So we can also use it for a recruiting vehicle. And please join us if you're in town. And then lastly, we always want to be continuously growing as engineers. So we want to be able to collaborate on design. We don't really need or want a role as a data starchitect. We want everybody to be able to figure out how things should be created and to participate in that process. And to that end, that means creating documents like RFCs, requests for comments, a way to collaborate on a technical design and get feedback that helps improve that design. We also want to get better at publishing release notes, describing in detail what we've built. That can be a collaboration with product owners, but that can go out to stakeholders as well as other engineering groups. We want to get better also at production support. And some ways that we can do that are adopting a very clear incident management process, conducting blameless learning reviews, so when something does go wrong, we're able to get down to the root cause and figure out how to fix it and make things better for the next time. And then also creating service level objectives and service level agreements to set expectations with our stakeholders and with our teams. So that's it. Thank you, everybody.
All right, thank you very much. Anonymous asks, why GCP before AWS or Azure?
Yeah, that's a good one. So I kind of glossed over it a little bit, but we are actually in AWS, and I consider AWS to be our legacy cloud environment, but there are certain constraints that make us choose to run some systems there. For example, we have our subscription platforms running on top of Oracle, and we're not able to run Oracle in GCP at the moment. So that drives that whole set of applications over to AWS. In addition, we have things that were just originally built on AWS that we haven't moved over to GCP yet. So it's not really a multi-cloud strategy by design, but it's where we are at the moment. And as far as Azure, we haven't really considered that yet, but I wouldn't rule it out.
All right. And from Ricardo, how did you deal with GDPR, specifically about permissions across the company and the right to be forgotten?
That's a good question when one is in Europe. GDPR was crazy. That was another deadline that we just made. So we created a completely separate data governance team. We spun that up as a group within the data organization, and it was their job to go across the entire enterprise and figure out how we were going to be able to comply. Our solution to meet the deadline was to create a set of manual processes that enabled us to comply. And now we're going back and figuring out how to automate those. So once we've figured out what we need to do in each case, now that we have those steps, we're able to figure out how to automate them across all the places that that data lives.
All right. Another question from C0D3 Guru. Why a vendor lock-in with GCP or others, AWS, Azure, when you could have used OpenStack, which could have run either in cloud or bare metal? Was there a cost estimation taking in account all or most possibilities?
I think for data, for us, it was a no-brainer with BigQuery. The absolute lack of operational support that's needed really made it an easy decision for us. So that enables us to move so much faster than other solutions. So as I mentioned, in AWS, we ran Redshift. We ran our own on-prem Hadoop cluster. We fought all those operational battles, and then when we tried out BigQuery, they just weren't there. It just wasn't a thing. So that was the path of least resistance. And we're able to work fairly closely with Google and get some attention from them, which helps assure us that we're on the right path and that we're not going to get stuck.
All right. Daniel wonders, how do you test your pipelines?
It's always really hard. We're trying to figure out how to do that in a better way. The sad answer is we're all over the map, so there's all different ways that we do it, but it's something that we're trying to improve on.
As always. From Anonymous, can you give an estimate of the running cost on GCP?
That's a tough one. I'm not sure if I could even give that just for data, but to get a little bit deeper into that, we've got multiple organizations on GCP, and then we have multiple teams. So not just the data organization, but all of our application teams. So I would estimate it's in the probably the hundreds of thousands of US dollars, but I don't know what the exact number is.
And Daniel again asks, how much data do you have, and what are the sources of that data?
Size-wise, I don't know if I could give a good estimate. Probably like 2 petabytes in BigQuery, but then there's GCS, there's stuff stored in S3, so it's hard to estimate that. But as far as sources, we have internal data coming from our print and digital subscription platforms. We have customer care data, which is the system by, if you have a problem getting your paper delivered or you want to cancel your subscription, we deal with all of that data. We have advertising data, which is a lot of volume. We also have all of our clickstream data, which is a lot of volume. And then we have data related to all of our marketing campaigns, which can happen either on platform or off platform and various social networks. So a lot of data.
A lot of data. Good for the conference. Mark, would you call part of your new architecture a data lake?
I would. I kind of think of that as a dirty word these days, but, or, you know, people always say data lake, data swamp. I think of all the data that we store in GCS or S3 as part of our data lake. So I think the answer to that is yes.
Another question from Anonymous. How long did the initial load of migration take?
A long time, because we had to do it again and again. So I think it was measured in days. We still haven't loaded all of the historical data that we have from our data warehouse. So that was, at least 15 years old. A lot of that data is still sitting in GCS waiting to be loaded. But yeah, it takes a long time.
Another question from Anonymous. If you started from lift and shift, how have you ended up with BigQuery?
Oh yeah, just to clarify that. So we didn't do a lift and shift, meaning in our old environment was Oracle, Informatica, business objects. We could have just ported that all to, say, AWS. We didn't do that. We knew from our evaluation of BigQuery, from the POC that we did with our clickstream data. So we did that POC using PubSub and Dataflow, and then the data landed in BigQuery. We knew that made the lives of our analysts and data scientists so much better as far as ad hoc querying and writing queries that they needed to do analysis, as well as building models. Their reaction was so positive that we knew the answer had to be yes to BigQuery. So we didn't want to do that lift and shift. We didn't want to give them Oracle again. We didn't want to give them Redshift or the equivalent again.
All right. From Balint. Since you had teams for both legacy and new systems, how did you bridge the gap in priorities between them? I would imagine the support team's focus on uptime made it harder for the migration team to make changes.
Yeah, it was really tricky. So luckily, the data warehouse the old system was in a pretty much steady state. So we only really had to respond to production issues and fires. So that team wasn't really building out new features. Now, there were some new features that they built there because it was unavoidable, but we then had to replicate those in the new system. So our primary goal was just to minimize anything that was built new in the old system and just focus on keeping it alive.
Which executor did you use in Airflow? Have you tried the Kubernetes executor?
Yeah, we have tried Kubernetes, but in order to keep things simple, we just went with the one compute node per Airflow instance. That way we knew if it went down, it was easy to stand back up. We do have some teams running Airflow on Kubernetes, and they're having success. Our data science team actually does that a little bit.
All right. From the Crunch Monster, great name, anybody who out there? Do you follow a prescribed agile process like Scrum or SAFe?
Yeah, most of our teams follow agile methodology. So we have daily stand-ups, essentially Scrum. We do the expected ceremonies, we do retros, we do grooming and planning, all that kind of good stuff. So it does vary a little bit from team to team. That's within engineering. The rest of our data group kind of depending on the size of their projects and teams, might follow a different route. But as far as the technology org in general and engineering in general at the New York Times, it's pretty much all Agile and Scrum.
Cool. Looks like we have time for one or two more. What did you do with the legacy team after the GCP launch?
They were majority consultants, so they rolled off the project and onto another project after we launched.
Easy enough. And to bring up the topic of two talks from yesterday, for Kafka, do you use the Confluent platform?
We don't. So the team that uses Kafka at the New York Times, if you've seen any of our talks about that or read the blog post, there's a good blog post by a fellow named Berga that runs our publishing pipeline team. That system uses Kafka. They are looking at the Confluent platform, but at the moment they don't. It's just self-hosted on GCP.
If you want, we have three more. Do you want to power through?
Cool.
What is the visual tools used?
The main one is Chartio, and that was chosen after an evaluation of sort of the usual suspects that are out there right now, so Tableau, Looker, and a few others. We do use Tableau in a few places for some teams, but by and large, it's Chartio as our main tool.
For how long have you operated parallel, if that is the case? If you've worked in parallel, how long have you been working that way?
I think that means that the two teams that were working on the old world and the new world, they ran in parallel for a little over a year.
All right. And for the final one, how do you expect Airflow to evolve in the future? Functionalities, usage around the organization. Can you tell us more about the integration of Airflow with Spark?
I expect that we'll be using it more and more. I think it'll become the spine of our platform. It'll be our main orchestration tool. We'll use it for our infrastructure and data engineering. Data science will use it. Other teams that need to create pipelines, I'm hoping will also adopt it. And yeah, I hope it's sort of like the main part of our platform. I'm super into it. As far as the integration of Airflow with Spark, we just use it to spin up Spark clusters on using Google Cloud Data Proc. So.
All right. Well, thank you very much. Most questions.
Thank you.